Video text tracking is a crucial aspect of computer vision perception in real-world scenarios, particularly for dense and small text. Existing methods are divided into two paradigms: three-staged pipeline and end-to-end pipeline. However, end-to-end pipelines are computationally expensive for high-resolution videos and destroy spatial correlation by slicing images into areas. Therefore, a three-staged pipeline is adopted, viewing video text spotting as a small object detection problem. The proposed method consists of two main components: PP-YOLOE-R network and sort algorithm. PP-YOLOE-R is an efficient anchor-free rotated detector, achieving 78.14 map on the DOTA 1.0 dataset. The sort algorithm is a simple and fast method for multiple object tracking. The overall architecture is depicted in Figure 1, where the video is divided into image frames, and the PP-YOLOE-R network outputs rotated detection boxes in each frame. Semantic information and character-level annotation are less effective for dense and small text due to severe image degradation. A two-stage network is proposed, ignoring textual characteristics and focusing on small object detection. The method is evaluated on the DSText dataset, demonstrating competitive performance on small and dense text spotting. The proposed method's efficiency and accuracy make it a competitive solution for video text tracking. The use of PP-YOLOE-R and sort algorithm provides a robust and fast approach for this task. However, the adoption of a three-staged pipeline may not be as efficient as end-to-end pipelines, and the method's performance may degrade with increased video resolution or complex backgrounds. The PP-YOLOE-R network is an anchor-free rotated detector that outputs rotated detection boxes in each frame. The sort algorithm is a simple and fast method for multiple object tracking. Key mathematical concepts used in this research include object detection, tracking, and computer vision. Figure 1 depicts the overall architecture of the proposed method, consisting of the PP-YOLOE-R network and sort algorithm. The method's performance is evaluated on the DSText dataset, demonstrating competitive performance on small and dense text spotting. Future work may focus on improving the method's robustness and exploring the use of more advanced algorithms for video text tracking. A novel approach for dense and small text tracking in videos is presented, with the overall architecture illustrated in Figure 1. The method employs the sort algorithm to assign a unique trace ID to the same small and dense text across frames, enabling accurate tracking. The ICDAR 2023 DSText dataset, comprising 50 training and 50 testing videos from diverse scenarios, is used for experimental evaluation. Each text instance is labeled as a quadrangle with 4 vertexes at the word level, accompanied by transcriptions and trace IDs. Implementation details reveal that the experiments are performed using Paddle on Tesla V132G GPUs, with the PP-YOLOE-R network serving as the basic architecture. The network is trained on the ICDAR 2023 DSText dataset, with the momentum optimizer and an initial learning rate of 8E3. The model is trained for 36 epochs with cosine decay schedulers and linear warm-up for the first 1000 steps. Data augmentation techniques include random flipping, rotation, and cropping. The visualization of small and dense text tracking results is presented in Figures 2 and 3, demonstrating competitive performance in various scenarios. The same color represents the same trace ID across frames, indicating the method's ability to track small and dense text accurately. The results are visualized by cropping and enlarging local areas due to the high resolution of the original videos. The proposed method achieves state-of-the-art performance on the ICDAR 2023 DSText dataset, with precise tracking of small and dense text in complex video scenarios. The Multitask Learning for Joint Detection and Tracking (MTLJDT) system is a novel approach to addressing object detection and tracking challenges in diverse scenarios. Experimental evaluation of the MTLJDT framework shows its ability to accurately detect and track objects of interest, such as pedestrians, vehicles, and sports equipment, in various environments, including game, activity, driving, and indoor street scenes. The MTLJDT framework jointly optimizes object detection and tracking objectives using a multitask learning framework, enabling the model to learn shared representations and contextual information. This approach leads to improved performance in both tasks. The framework is formulated as a minimization problem, where the objective function combines detection and tracking losses. The detection loss is the sum of classification and regression losses, while the tracking loss is the sum of association and regression losses. The optimization problem is solved using a stochastic gradient descent algorithm with momentum. Experimental evaluation on benchmark datasets, including MOT16, KIT-TI, and Caltech Pedestrian, demonstrates the MTL-JDT's state-of-the-art performance in both detection and tracking tasks, with significant improvements over existing methods. The impact of various design choices, such as detection and tracking architectures, on the overall performance of the MTL-JDT framework is also investigated. The results suggest that the proposed approach is robust to different design choices and can be easily adapted to various application scenarios. The MTL-JDT framework's objective function is defined as a weighted sum of detection and tracking losses, as shown in equation 1, L equals lambda 1, L underscore det plus lambda 2, L underscore track, where lambda 1 and lambda 2 are hyperparameters controlling the relative importance of detection and tracking losses, respectively. The approach has limitations, including the requirement for large amounts of annotated training data and the potential for overfitting. Future work directions include exploring alternative optimization algorithms and extending the MTL-JDT framework to other computer vision tasks. The novel approach presented in this research paper involves dividing small and dense text tracking into two subtasks: text detection and tracking. By reframing the task as a small object detection problem, the authors leverage the state-of-the-art PP-YOLOE-R model as their base model. This model's strengths in object detection are harnessed to tackle the complexities of text detection. The incorporation of the sort algorithm enables high inference speed, facilitating the accurate tracking of localized text. This is achieved by efficiently assigning unique identifiers to detected text instances, ensuring consistent tracking across frames. The algorithm's effectiveness in handling complex scenarios, such as text overlap and varying font sizes, is demonstrated through visualization of tracking results on various scenarios. The proposed method's performance is validated through comprehensive experiments, showcasing its ability to accurately track text in dense and small scenarios. The visualization of tracking results provides a tangible representation of the method's effectiveness, highlighting its potential applications in real-world scenarios. By addressing the challenges inherent in small and dense text tracking, this research contributes to the advancement of text tracking technology, paving the way for future innovations in this field.